All right, I think that is a little bit enough from me. I think it's time right now to ask the guy that was really responsible for all of this, the guy who started the Axon Framework quite a few years ago. And I'm very proud to introduce Allard Buijze to the stage. Please give him a big applause.
All right, good morning. It's good to see so many of you turned up. It's always a bit exciting and a bit scary if you send out an invite to a party and in the end nobody shows up. Fortunately, that's not happening this morning. I will not say if that ever happened to any of my other parties. I'll leave that to you to guess. So then, for this slot, we chose the title "Microservices. Who cares?" And there's a bit of an angle to this. It might be seriously, who cares? Just let the other guys do microservices, and we'll do serious business. But it also might mean, yeah, so I'm doing microservices. Who cares? It's not a cool thing, even though if you go to conference nowadays, it's either you do microservices and you're part of it, or you don't and you're not, right? So as Jeroen said, historically I sort of stumbled upon a little problem in the past and started experimenting with that, which evolved into Axon Framework, and since a couple of months also into a separate company. And Axon Framework originated from well, love is a big word, but from DDD and CQRS. It's really it helped me solve specific issues I had, and I used Axon to basically help me, or I started experimenting and then build Axon, which helped me implement these DDD concepts in a better way. As Axon evolved, I noticed that Axon is being used a lot in microservices environments, and that was a very interesting thing for me. And that is actually one of the reasons why we believe in the latest months downloads are going up significantly, because of course there's a lot of buzz around microservices. But that also made me wonder, okay, what is the relationship between microservices and DDD in that case? And although I don't mind being on stage and telling you all about it, I believe that this may become a sort of a very subjective talk, and it's just, hey, we from AxonIQ believe that this is the way you should be thinking about software. And instead, we decided to invite one of our friends on stage to do that for us. So I'm going to invite Michael Plöd to the stage. Please give him a warm welcome.
Hello.
And yeah, can you explain a bit about this relationship and how does that work?
I'll do my best. Okay. Thank you very much for coming in these big numbers to this talk and to this conference. And what I'm going to talk about now is the relationship or the friendship or the love between domain-driven design and microservices. Just a few words about myself. My name is Michael Plöd. I come from a company called InnoQ. I'm a consultant, mostly busy in the DDD domain, doing a lot of consulting on that. You can also follow me on Twitter, @bitboss is my nickname. And the first thing I want to talk about is the mysterious bounding context. Like every, let's say, piece of literature you see around domain-driven design and microservices, one of the first quotes you'll obviously hear in the microservice context is some reference to Conway's law, and another quote is probably model your microservices along bounding context. That's one of the standard quotes in the microservices community, obviously. Now, what is this bounding context? In my eyes, the bounding context is a fundamental shift in terms of viewpoints, going away from, let's say, centralized service-oriented IT to a rather decentralized IT landscape, because the bounded context in its essence is the boundary around the meaning of a certain model. Now, what does that mean? Basically, it means that I can model a customer. Let's say I'm a visitor at this conference, and the folks at AxonIQ did a great job in organizing this conference. So you all registered in this conference or for this conference. So in this context of the registration, I can see the customer in a very CRM kind of way, like in a classic IT modeling. Now, when I go to my stepdaughter who's studying business informatics right now and tell her, go to your UML tool and model a customer, she would come up with something that would be like in the context of the registration, a very suitable model for the customer. But now let's switch the context. We all want to hear, for instance, for a multi-track conference, various talks. Some people want to go to Alberto's event storming workshops. Others want to go to some other workshop or some other session. Now we have some preferences. Or we have meal preferences. We have people who are eating meat, people who are vegetarians, people who are vegans, and whatever. Now, do I need to model a customer in a way like I did in the registration context? No. The customer becomes a lousy sign on a piece of paper. Yeah, we have one vegetarian, one meat eater, one who's interested in Alberto's session, or for instance. So that means we can look at things very differently. And that is actually an enabler, a very important thing for the idea around microservices. Now, one of the key questions that often comes up when modeling microservices or bounded context, hey, what are the drivers for like making these boundaries? And there is no general rule of thumb here. One rule can be time. Now, if you have things that are happening way later in a certain process, for instance, imagine a mortgage loan being finally repaid, the very last payment. This is 10 years probably, or 20 years away from the application for that mortgage loan. That can be a driver. Another driver, and a very important driver, is something like cohesion and coupling. How do certain things fit together? Do they really fit together, or are they in a certain way differently? The next one is the meaning of a model. For the meaning of a model, that was the first example I gave with the conference context. The meaning of a customer between like the conference management and the, let's say, the registrations is totally different. And in my eyes, the most important driver for identifying bounded context is the language that is spoken in the project. Domain-driven design is highly driven by an idea called the ubiquitous language, which means this is a mandatory language for teams, like from documentation, language in meetings, language in bug tickets, but also language in the code. Now, I'm from Germany, and what I see very often that you have a German specification, the meetings are in German, and suddenly you see developers translating all the business terms with Google Translate to English. That is not what the ubiquitous language is actually about. And we can talk about certain things that are physically the same in a very different way. And this is a very important driver for deriving bounded contexts. Now, why is the idea of a bounded context so important in the context of microservices? First, it enables an independence of the model. So we can create models that are independent from each other. So we first look what we have in our context, and we find the perfect model for that context, for that given microservice. And then we take a look later on how we interact with other contexts. There are various patterns in this area. Those are mostly in the chapter context mapping. I'm not going to talk a lot about context mapping today because time is a bit limited. But the first thing is you focus on your context, you get the model in your context right, the way you see it in your context. Afterward, you look outside. And it also enables a team independence. One of the key, I would say, cultural, organizational drivers for microservices is basically having independent teams that get away from a project deadline thinking towards a product thinking where we are actually in the agile storyline. Now, as Allard already said, a lot, or what we saw in the motivational video up front, which is supposed to go viral from today on, was the talk about monoliths. Now, the question is, are monoliths a roadblocker in terms of adopting DDD, in terms of going to microservices? I would say no. And this is something that where I'm a little bit unhappy about a lot of the discussions, because I hear a lot of words that go like, DDD, when you use DDD, you avoid creating monoliths. I say this is nonsense. In my eyes, DDD is an enabler for creating really good, maintainable, and decomposable monoliths. Now, let's take a look what DDD has to offer for us. The part for that is tactical design. This is the way how we internally structure our applications, our bounded contexts, for instance. And this is basically I would say, the bounded context and the context map, the interactions between the contexts, they are more or less an enterprise architecture kind of thing, whereas the tactical design is rather I would say, internal software architecture kind of thing. And tactical design basically consists of, I would say, 3 major parts, and in my eyes, 3 add-on parts. The first major thing in tactical design is the entity. And a very important, let's say, note here. The DDD entity, to the Java folks who are using JPA, is not your JPA entity. It's a business entity, it's not a persistence entity. It's very important. This thing here contains logic, it contains business rules, and so on. And the entity is identified, for instance, by a business identifier that is constant, like a customer number, an account number, for instance. It's also the core element in your domain. And it has its own life cycle. On the other hand, the value object is rather a value container. It contains some logic, but it's let's say, a second-class, let's say, contender in this game. And its identity is mostly derived from the attributes. Let's take a look at one thing that costs 10 euros. So obviously, in an e-commerce store, 10 euros are a value object. But when I go to the factory that's printing euro bills, those specific 10 euros are an entity. So if something is an entity or a value object, highly depends on the bounded context and the meaning of the model we're in. So an address can be an entity in one context, a value object in another context. And now putting all these things together, we have the aggregates. And the aggregates are, in my eyes, the main driver for having highly decomposable, very well structured software applications, be it microservices or be it monoliths. Why? Because they are a grouping of entities and value objects, and they are a consistency boundary as well. So when you want to update an aggregate, you usually want to have 1 transaction per aggregate. So when you update 3 or 4 aggregates, that would go along in 3 or 4 transactions. And that means, on this way, you have eventual consistency between the updates. The next thing is, when you want to reference from one aggregate to another, you don't go ahead and do this directly. You do that by the identifier of the so-called root entity, which is the only way you can step into an aggregate. I will come back to aggregates on my next slide with an example that makes those things a little bit clearer. In addition to those main parts, the aggregates, the entities, and the value objects, we have 3 other aspects in terms of tactical design in DDD. One is the services, also often referred to as application services. Application services are responsible for logic that contains orchestration, that contains loading of stuff, that contains access to commands. I think Allard will talk about commands later on a little bit. And the most important thing here is your main logic is in your aggregates, your entities, and your value objects. And those services, they're only there for orchestrating those business rules, orchestrating this logic. The factories are basically the typical GOF, Gang of 4 factory pattern. So when you want to externalize the creation of aggregates, do that in a factory. And another very important thing are repositories. Repositories are here for persistence. This is where your data access layer is located in. This is also where your persistent entities, your JPA entities, actually count in as well. And in pure DDD form, also the storage and caching subsystems. Now, let's take a look at those aggregates a bit. I have an example here. Those are 2 aggregates. We have one big loan application form and aggregate and one rather small customer aggregate. Now, when I go from the loan application form to the customer, I don't say loan application form get customer. I would say loan application form get customer number. And it wouldn't, for instance, be allowed to reference from the customer directly on the loan because the loan is not the root entity of that aggregate. Now, I would actually prefer having small aggregates. Like, I usually prefer having a few entities and a lot of value objects in those in order to make these things really decomposable. And you can also, when you step over to the persistence part, you can actually also go ahead and think about referential integrity. Do you really need foreign key constraints between 2 references of aggregates? Eventually you want them, but eventually you also want to have a decomposition already on this level. Now, that's about the internal building blocks or the tactical design. Now, going a little bit further, there's another construct in DDD, which is very, very popular, I would say, in the new school of domain-driven design. And this construct is called the domain event. Now, the domain events are something that happened. Please mind the past tense. In the past, in the business domain, that domain experts deeply care about. An example, what is not a valid domain event? On-mouse, over-event, on-mouse, clicked event, and whatever. This is something that domain experts don't care about. But credit application approved event, or credit application submitted event, or credit repaid event is something that domain experts certainly care about. And in the last couple of months and years, this construct is getting more and more important. Now, when we look about triggers of domain events, what triggers a domain event? We see one option would be time. Let's say a timeout. We send out a contract to somebody, but they don't send it back signed, so we withdraw our offer. User actions. I am handing in a contract or an application for something, so I, as a user, do something. Other events are also a possibility. Let's say we have a negative scoring result on a credit application. Now, in this case, we automatically want to decline the application. So credit application declined event is getting automatically triggered by that. Or other applications can trigger events as well as documents. So when we send in some paper to a company, when we sign a contract, this is also something that can trigger events. Now, in terms of identifying events, I do not want to lose a lot of time in this keynote today, because you have a great workshop today waiting for you by Alberto Brandolini on event storming. And event storming is a workshop moderation format that helps you in identifying domain events, and I can highly recommend you to take a look at that. But we can actually take this idea of domain events a little bit further than that. We can use those domain events for persistence using event sourcing and the CQRS pattern as well. So we can make these domain events first-class citizens of our persistent model. And I'm very sure when we put all these things together, the concept of domain-driven design, the concepts of the internal building blocks, and when we take a look at all these concepts, we can create very good monoliths that are really stable, that are highly maintainable, that are decomposable, and we can also create really good microservices. Now, Allard, can you tell me how AxonIQ is acting in this area and how AxonIQ is implementing a couple of these concepts?
Thank you for that for the introduction. Waiting for my sound. Yeah. Thank you, Michael, for that introduction. So at least now you've heard it from somebody else, right? I've been I could have explained something that would probably have been very similar, but it's good to have somebody else here. So what Michael just explained is really the background of Axon. This is the stuff that I've been struggling with for the last, I guess it's 8 years now, and out of which Axon Framework was developed to just help me with some of these problems of, okay, how then, I mean, this is all nice theory, but how does it work at runtime? In the end, the only thing I really care about, I mean, pictures are nice, but I want to have software running. Right? I want to press that play button, and I want to see the stuff getting done. That's the thing I care about. So Axonic is about Axon Framework, and Axon Framework will help you build these models, right? It helps you with these DDD and CQRS principles in having you build a model that is good for whatever you're trying to achieve, right? And event sourcing is another way. Event sourcing can be pretty complex. If you want to get that running reliably, I mean, you can do a proof of concept and get some code up in 20 minutes probably. Don't need a framework for that. But you're very likely to run into the same mistakes. I mean, I've made some really stupid mistakes in the past, and I would feel very bad if the knowledge I gained from making those stupid mistakes wasn't shared with the community. So basically, you get event sourcing out of the box, and even though it's not that hard, in the end, it's not what you're getting paid for to do. Right? In the end, it's about getting your business running, getting that business logic up. Every second you spend on something that is not that is a second lost. And the way Axon does that is by forcing very strictly the abstraction between the technical aspects of getting an application to run, especially in these concepts of DDD and CQRS, and the functional aspects. And in an ideal world, we just have to define these functional aspects, and the rest is just automagic. Right? But we all know, we're all developers, we know automagic works for 99%. And that 1% where it doesn't work, that's taking up 4 weeks to just find out what's happening. So it's not an ideal world yet. There will be more versions of Axon coming, don't worry. And we'll get there. We'll get to that ideal world someday, I hope. And of course, abstraction is really nice, but abstractions don't do anything at runtime. So Axon Framework contains and will still contain implementations for building blocks, like some of the event stores that are currently available in Axon for storing in relational databases or some of the NoSQL databases. There will be integration with other messaging systems, etc. As Jeroen said, well, we are committed to continuing development on Axon. It is Apache 2 licensed and will remain so for well, forever if it's up to me. Now, Michael said that these domain events that you emit from your aggregates, they can be used to implement event sourcing. And why would you do that? Well, basically, it comes down to they carry value. Things that happen in the past tend to maintain value over time. There's something that we can learn now from stuff that we did a long time ago. So if we just have so-called ephemeral events, so you just publish an event and then lose it, you've got two issues. First of all, it's technically very dangerous. We'll not get into that. But the second is, you don't have an explanation anymore on why things are the way they are right now. Right? If you like history, it's probably because you like to know how things are the way they are now. What decisions did these people make in the last centuries that made us behave the way we do now? So just to make sure we don't have to do any IT archaeology and make sure that that's not going to be a major direction of studies in our universities, we better store that information. And of course, where do we store that? We store that in an event store. And what else could we have? Now, event store is a very nice concept, and again, you know, in theory, everything is nice and we're all happy. We're storing everything we're doing in the past. But then, you know, practice always has its own plan, right? The real world doesn't care about theory. So what happens is these, the event store that we use, they slow down over time. And here you see a graph of a benchmark that we've been running for the last couple of weeks. It's limited to 100 million, even though the graph is limited to 100 million events, even though the benchmark ran for much longer. But what you see here is that on the horizontal axis, you see the number of events stored, and on the vertical axis, you see the increase at which, the speed at which the events are being added to the event store. Now you can imagine if you run a benchmark on your local machine or you do a POC in a project, you stick to that left area, right? You probably won't store much more than 10 million events during a POC. And all's good. We're all happy. Let's get this bugger into production. And then, of course, in production, you get to the part on the right. And it doesn't perform anymore. Unfortunately, fortunately, we have a few customers that unfortunately had this problem. And there are ways to solve them. And they are usually a combination of very expensive database engineers that are going to tweak your database so that it brings the line up, right? Or it moves the line a bit to the right so that that massive slowdown will only happen later. But that's just postponing the inevitable. And that's something we don't like. We have customers that store 1 billion events a day. So that's 10 times that graph every day, day in, day out. So what about, that's what was literally one of my questions to them, is like, okay, how much value do they have? If they bring you that much trouble, why not throw them away? Like, ooh, I said it. And their response was very genuine, and because it came really fast. It was, oh, no way. I'm not going to throw this data away. This is very valuable information. Okay, why? Well, two things. We have to store everything. It's our auditing source. The government requires them to store everything for 7 years. Just imagine 7 years, 1 billion a day. That's massive. And the other thing is they do analytics on it. They are looking for certain patterns that indicate cheating, forgery, or any malicious thing that people would want to do. So for them, it's a reason to, it's a way to stay in business, actually. So this problem needs a solution, right? We need to find a solution. If we look at event store, and the operations are actually pretty simple on an event store. The main operation is append. We want to add new events to it, right? And the only thing that we really need to do in append, besides storing the event, is to make sure that sequence numbers are correct, that we don't run into concurrency problems because of some logic happening on two machines simultaneously, and making essentially false decisions, right? Decisions based on false data. So appending, that's pretty simple. Any database can do that, right? An insert is just a plain, simple SQL thing, so everybody can do that. Then there's reading. Now, given a certain event stream, we want to reconstruct some domain concept, an entity or an aggregate, in our application, and we can do that based off of these events that it emitted in the past. So we need to be able to read specific events from that stream pretty efficiently. Now reading is always from left to right, at least in an event store it is. But in the case of an aggregate, we need to jump every now and then because there's a lot of events in there that are not relevant for reconstructing that aggregate's current state. But there's another thing to this pattern, and the fresh data, so the data that has been most recently inserted, is most likely to be touched of all the data in there. So very old data is very unlikely to ever be needed again. So there's very few reads on that. And that is something that relational databases, and actually most of the NoSQL databases as well, aren't optimized for. They optimize for being able to access any data at any time. And they are reasonably fast at that. But then there's a payoff, which is the last data, which we care about, is a bit slower. Now the third pattern is the full sequential read. So imagine we've stored our billion events a day. We've learned a new machine learning technique to find new patterns in, that might detect fraud. We want to be able to do a full replay of everything to either train or just run the operation. Now we would need to go from the beginning all the way to the end. On file system, that is very simple, right? You can start at the beginning of a file and just read all your way to the end. In a database, especially relational databases, it's possible, but it's hard. They're not optimized to give you everything, right? Of course, you can do a select star, but what about ordering? How do you guarantee that they come out in the right order? Trust me, relational databases with billions of rows in a single table, they don't like this kind of operation. Hibernate doesn't like it either because it will load an entire set in memory first before returning it to you. Well, imagine that with an unlimited set of data. So that's why we thought, well, maybe, it sounds like a really stupid idea, just another NoSQL database. Who was waiting here for just another NoSQL database to appear? Exactly. Neither was I. I was like, okay. We've been looking for a NoSQL database that would help us do this. And either we didn't look good enough, or we didn't look well enough, or it just didn't exist. But we decided to build our own. It's file system based. As I said, file system is pretty good at if you open a file from reading from the beginning to the end of the file. Operating systems have optimized to do that. But then these streams are potentially unlimited, right? So we chunk these streams into segments to make sure that we have multiple files in a row that help us do that. The Axon Event Store that we've built currently uses a replicated single master model. So you can have a replicated setup, 3 nodes, for example, where a single one would be elected master, and it would make sure that all these consistency rules aren't violated. If that master fails, the replicas will elect a new master, and as long as there's a majority alive, you can go on. So this serves both as a data reliability approach, as well as an availability of the system itself. Of course, we cannot prevent crashes. Things happen, right? They never happen in a lab, never happen in theory, but practice doesn't care. So it knows how to recover from a crash. And we've made sure that if data is corrupted in some way, somebody put a magnet next to your disk drive, we'll be able to discover that. Now the index, that is a special thing, because that the most recent data is accessed most. Normal indices that we have, the generic index, the B tree that we have in a relational database isn't very suitable. So we've built special indices to make sure that we can access the recent data very fast. And of course there's a trade-off in the sense that when you access really old data, it will take a bit slower. And the thing, of course, I like most is the fact that it's a drop-in replacement for the Axon Event Store. So we included that in the benchmark, and you have to know that we've had many discussions with people that said, no, you're not going to build another NoSQL database, right? Not again. You don't want to be doing that. And yeah, we know, but we can't find anything else. So you start building this, and it takes up a couple of weeks, optimistically said. And then in the end, we can finally run a benchmark. And Mark and Frans were heavily involved in creating and running the benchmark. And we were actually pretty happy to see that this was the performance graph over time. Now, the height of the line shouldn't say too much, although in the previous slide I did have the machines that we've used. These are Google compute machines. So for the relational database, we've given them one node. So it's not a high availability setup, but at least it's a durable. It has durable storage. We gave it 30 gigs of RAM, 8 CPUs, and a terabyte of hard disk. And we want it to be a fair game, right? So for AxonIQ to have durable storage, we need 3 nodes at least to guarantee that transactions are safe from a single node going down. So we gave them less RAM each, less CPU. So we've got in total less than what the relational database was given. And this is the result. So not only is the event store faster than a relational database, which is nice, but you can tune a database, and as I said, you can get that line up. But more importantly, it does not degrade as you insert data into it. In fact, there's a little bit in the last part, it's slightly higher than where it started. So it's probably just getting excited about its new job and ready to run just that bit faster. And I'm proud to announce that we have our beta program right now. So if you're interested in using the event store, it is not for public download yet, because we do realize it's a database. It's a place where you store your most valuable asset next to the human beings in your company, which is the data. So we want to be really sure that your data is safe before we start saying, hey, here's a download and put all your sensitive stuff in here. If you're interested, just contact us. You can recognize us by the shirts, of course, and we'll be happy to sign you up. Now, another topic in Michael's story was evolutionary microservices. Right? It's the monolith is not a bad thing. The big ball of mud is, and if you don't pay enough attention, your monolith will turn into a big ball of mud and become unmaintainable. But it doesn't have to be so, as long as there's good structure, right? And these contexts, they help building that structure, as well as the aggregate, etc. And that is, an aggregate is a very important concept in Axon. Axon really forces you to divide these components, or at least to divide your big model or models into specific components. And you can deploy them as one if you want to, but either at the beginning or at some point in time later on, you can decide to deploy them separately. And the reason to do so is generally non-functional. Sometimes it's just because it's cool. It's not a really good reason, but in the end we have to be happy in our job, so why not? But generally they're about maybe the application lifecycle or that component's lifecycle is completely different. We need to do 2 releases a day to be able to keep that up to speed, right? We don't want the release cycle of the big monolith to drag innovation on some other component. Or maybe it's just because of team size. We've grown too large. We have to split the team to become more efficient. Well, let's work on different code bases as well then. Let's deploy separately, separate components. And we can move on and on like that. Now, if we zoom into that middle part, so we have our two components sitting there. If you look at the role of Axon Framework in here, Axon Framework basically organizes the messaging within a single JVM, right? So there's a command bus, an event bus, and all the goodies that you get. They work fine within a single JVM. So if everything was in a single component, you'd be done, right? But now they're in separate components, so somehow we need some messaging in between those. And although Axon gives you the third-party integration and allows you to connect to third-party messaging systems, there's still a few challenges there. Now let's look at the reasons. Why will we send messages? And Michael already talked about the event. And the event gets a lot of attention, especially in the last 2 years in domain-driven design. Event is a first-class citizen, right? It's up there with the rest of the guys in terms of building blocks. But if you look carefully, there's more. There's actually 3 reasons why you would ever want to send a message to another component. And for the last 2 years, I've been trying to hunt for number 4, and I still haven't found it. So that can mean 2 things. Again, either I'm not looking good enough, or it's just not there. If you've found it, please let me know. I'm open to suggestions. But the other 2 are the command. So a component wants another component to do something, right? It has an intent of changing the application state. And the 3rd reason is I want to know something. I need some information now to do whatever I need to do next. And I know some other component has that information, right? And preferably you don't care or even know which other component that is. Preferably you just say, hey, I've got a question. What's the price of this and that product? And you just get the answers. And maybe you get multiple answers, like, oh, there's 5, 4, 3. I'll pick 3. That's the lowest one. It's the best price I can get. So that's why we're building what we call, at least for now, the Axonic messaging platform. It uses stereotype-based messaging. So all we know and all we care about is whether a message is an event, a command, and a query, because they have very specific routing requirements, delivery requirements, and maybe even storage requirements. Right? Events tend to carry value for a long time. Something that happened today, and hopefully this is an event that will be very valuable after a couple of years. But commands, once they're done, in most cases they're just done. We don't care about it anymore. A query, when it's answered, we don't care about it anymore. There are exceptions. And in some cases, you want to store the queries and the results as well, so you know who saw what at what time and why, etc. But we want to have consistent routing, of course. Message correlation is very important. So we have commands triggering events, and the events change models, and then we have a query which reports that changed model. How do we correlate all these messages? This is something that a lot of projects spend a lot of time on to get right, to make sure that all these messages are correlated. And lastly, of course, error reporting. If you're on the messaging middleware and you cannot deliver a message, that probably means something. It might mean a lot more than just, I cannot deliver that message. Right? There might be information in that error to somebody else, for example, some of the operations guys. And then there's metrics. So we see it as just enough intelligence, right? We're not on the left with the dumb pipes, which is very hip and modern. And the reason we are there is because the ESB has really let us down. well, unless you work for a consulting firm that implements them, because I think that's the only party that made good money out of them. So we sit there in the middle. We don't know anything about the contents of a message. We just know what type it is, and that we write it based on that. We're not going to do any transformations on any of the scary stuff that ESBs do. Right now we're in a phase where we're doing requirement analysis. We've been talking to many companies already about, okay, what are your problems right now? And again, if you want to join us with this, we would be very grateful. So yesterday, and this is the closing of this session. Yesterday, we've held the Event Store Hackathon. And it's always a bit scary. We've got this product, and of course, you feel that it works. But yesterday we had about 20 people over to start using it, and it was in a controlled environment. We were there. The doors were closed. It was safe, but still, it's sort of exciting. And the biggest complaint we got was that the application ran a lot faster with our event store than the previous one. So that was pretty exciting to get as feedback. Of course, we did get very valuable feedback as well. There's some developer friendliness that we can add to it, which was very helpful for us to get as feedback. But we we also had a prize, 2 prizes to give away yesterday. And I promised them to announce the winners today. So these are prizes for most valuable feedback and the most creative or coolest implementation or thing you would build and then on the event store. And for that, as the winners, I would like to invite David Calosi and Paul Siegman to the stage to collect your prize. Please give them a big hand. Congratulations.
Thank you.
Here's yours. Congratulations.
Oh. Congrats. Thank you very much.
Enjoy. Okay. Give him another hand. So this is just our way of saying thank you for great feedback. We're going to incorporate that. And yeah, it was really exciting to do. So all I want to say now, if you're interested in anything we said, come to us and let us know what you're interested in. If you have any feedback, please let us know as well. We are. This is one of the reasons why we organize a conference, is we want to start discussions, and of course among us and you, but also everybody here. So we have a great lineup today. We have great speakers, great talks for today. So have fun and yeah, enjoy the rest of the day.